this video is to create a Solana token 2022 uh, Launchpad. So for this, we already have pump.fun to create token 2022 tokens, but it has some limitations like advanced tokenomics. Token 2022 comes with a lot of extensions, but um, pump.fun and other similar plat launchpads only support metadata or metadata metadata pointer extensions. Now, this is our problem statement. Problem statement. Now, the goal is if I go to format and see Solana token 22 extensions list right here. I have this so and so set of extensions. Like uninitialized is one extension. There is transfer fee config, transfer fee amount, mint close authority, confidential transfer mint, confidential transfer account, default account state, immutable owner, memo transfer, non-transferable, interest bearing config, CPA guard, permanent delegate, non-transferable account, transfer hook account, confidential transfer fee config, confidential transfer fee amount, metadata pointer, token metadata, group pointer, token group, group member pointer, token group member, confidential mint burn, scaled UI amount, pausable account. Most of us would have used metadata pointer or token metadata, which gives the token the UR, the image, its name, and description, which we often see on explorer.solana.com. Better I go for solscan.io and open a transaction. This is an account. What I'm looking for is a token. Token. Let's see. Yeah, G2 token, let's say. The G2 token has its URL, sorry, the logo, the name, and its description, and its address. Everything uh, from the token metadata. It has its JSON object using which, again, like the token gets its logo, name, and the description. So that's like the famous one we use. And the other famous one is the transfer fee extension. So whenever party A transfers 100 tokens to party B, we configure transfer fee in such a way that 10% of the tokens gets withheld and non-usable, not usable in the user's uh, wallet, and the token owner can harvest those tokens and get kind of like a revenue stream. That's the second popular one, I would say. And the third one is the transfer hook. Let's see. Transfer hook. Transfer hook is an extension where, again, party A transfers X number of tokens to party B. There will be a smart contract program that executes for every such token transfer. So these are like the famous ones. But the goal is, however many extensions are there, um, yeah, build a launchpad that supports all extensions. Um, the UI, the UI should be in a way that the user wants to kind of select which extensions they want to configure while creating the mint token. Then the other point with pump.fun, it's not at all a problem, but it's just how pump operates. If you go to a coin, you can see that, hey, um, this is the token mint. These are the charts. I think I don't know how these charts are powered, but one way to power up these charts is via Gecko terminal. It offers an API where you give the pool address. It gives you the trading view chart, embedding chart, or the data. So we can get this easily. And the volume, etc., can also be retrieved from Gecko terminal. It offers a chat screen, etc., etc. But the main thing is, where does this token is being traded? If you can see, there is this liquidity pool. I'm not sure where this liquidity pool is hosted, but what we'll be doing simply is like we will basically go to meteora.ag and go to pools, and we'll be using DLMM pool with we'll just create a DLMM pool with the token mint. So the goal is we create a DLMM um, Meteora pool with the newly created token mint. So the pool has to operate with two different mints. So we'll basically do something like new mint being traded against Sol or wrapped Sol. So this is how whatever the token we create gets traded. So we kind of have, I mean, like we kind of accomplished how, you know, not only like creating the token, but also like how users can basically trade that token for Sol wallet. And there is this notifications part. There is this bonding curve, which we don't really need at this moment. And the trades. We can get these trades again from Gecko terminal. It's a free API, so that's fine. And here is like a very minimal UI where you can like buy and sell tokens. Um, yeah, I think that's about it. So We have this functionality in place, but how are we going to do this? We will do this in this way. First point, we will use Anchor to write smart contracts, smart contract instructions, which we will call from the front end to create the token mint with extensions. Second point, we will write API side code to create, yeah, we will, yeah, we will create the API side code to create the DLMM Meteora pool with the newly created token mint and with Parapsol as a paid. Third part is UI design. Probably, when I say UI design, I probably will be using AI to kind of spin up a basic UI. But again, like we'll explore how do we kind of like keep a production ready UI UX, not basic, but production ready UI UX. Um, and finally, so I think task one itself takes a lot of time because we'll be needing a huge set of instructions to create mints with different extensions, plus writing tests in TypeScript, and huge part making sure the tests are successfully. Okay. And also, like, what are we using on the API side? Plus, for the UI, we'll straightforward use like latest Next.js plus app router. It's Solana contracts. We'll basically use Anchor. Oh, what else are we missing here? Yeah, I think that's about it. All right. Let's start with initializing the project and let's go from there. So I want to save this as a notes in the project. So let me work YTL string token Solana token 2022 Launchpad. And now I want to do NPX. That's the command. Okay, okay, please send me that. So there is this new framework, GIL. I'm not going to be using that, but I'll be using the widely used Web3.js itself with the founder example. So again, tech stack API UI latest. Next is app router plus tailwind CSS. Let's wait for this to finish. There's also an option to pass in bun as an argument. I think that is hyphen hyphen bun, which uses bun instead of npm. That should be a lot faster than using npm. So let's go. All right. We have a project set up now. I'll copy this. I'll open cursor here. me create a small notes.md file. Okay. I think I will definitely be having some anchor environment issues, but let me see. Maybe use AWS. Okay. Let me see the latest version of Anchor currently. I go. Oh, I think the anchor build is done right now. Let me quickly run the existing counter example tests as well. All good. So let's proceed with erasing everything. Everything's whatever in Libaris. These are all the context. Yes. Let's remove this. And let's create a separate directory for instructions. Instructions. Okay. Mm, Let me drop it here. Okay. So now, um, what do we want? We want to add, let's open cargo, terminal, and why do we need it as a counter? Let's keep it as Launchpad. Launchpad. This is the ideal. We'll get to it. So, um, debug. Yeah, here's the ideal. This will definitely go away. So this is fine. Yep. Let me search for counter. It just will create unnecessary problems if you don't declare the product name properly. Yes, this is not relevant. Okay. Otherwise, let me change here as in Solana token 2022 Launchpad. Token 2022 Launchpad keywords. Let's do this. And okay, with that, release not counter Launchpad. This will clean the one. We don't really need that, so that's fine. Let it remain like that. Counter, this is the UI part. We'll use AI to kind of like generate the UI for that. So for now, let me create a mod RS here and another mod.rs in the instruction set. Create token. Anchor token 2022. Um, Anchor token 2022. Create with extensions, programs, GitHub. There will be an examples directory. All right. So let's start with, the basic one. Um, Create token with metadata. That's what uh, we get on pum.com. So let's start. So we need Anchor SPL. So for that, let me go to anchor.toml. No, cargo.toml. Add Anchor SPL, same version. Do an serial Anchor SPL token metadata. I think I hope this is the one. Yes. It basically gives us certain structs, let's say. Okay, that's what we need from here. So right now, let's start with declaring the context first. Use anchor lang reload and start by deriving accounts. Pubs, struct, create, yeah, just token with metadata. Lifetime info, go on. Account mutable signer info. This is correct. Um, no, we don't need this. What we need is the mint account and the system program and the token program. So declare the easier ones first. Pub system program, lifetime info, system. And then you have the token program, which is you get this as an inference, no, sorry, program info token in, that's it. Then you have the mint account. This is token 2022. Let's see from where we can get this. Now let's go with creating the token mint. Basically, first for creating a token mint, on the off chain, you kind of generate a key pair and you pass that key pair info to create a mint or like initialize a mint at that key pair location. So what is this? This is uh, I can say like mint account. This is an interface account, lifetime info and mint. Why isn't this getting the syntax highlighted? Because I haven't used this yet. Let me export it. Pub mod create token with metadata. Pub mod. Okay. Publish. Export everything. Now in librs, I will declare the module instructions and use instructions. I have declared the context here. Let me continue declaring context. So I have to initialize this one. Yeah, I think this is what I want. Pair is the signer. Um, I don't need to declare a space for this one. Decimals, I will take this as an argument. A function process create token with metadata. Oh, no, let it be like this. Process create token with metadata. Context, you have the token name, token symbol, token URI. The reason why I declared this car, this one package, anchor SQL token metadata. If I explore this one, readme documentation. Yeah, token metadata struct. I can basically use this struct instead of passing, I mean, like individual arguments. Um, use anchor SPL. Just wait a second. Let's refine this one later, but yeah, let's go with token metadata args. That's what I was looking for. Token metadata args. Okay. So this is what I want, but I also want the decimals, etc. without hard coding. So let's define this one later. So token name, which will be a string, token symbol, which will be a string, token URI, which will be a string, and I also want the token decimals U8, uh, token supply use. That's it. Now I want to remove this hard-coded line. So what I'll basically do is I'll take this into the context. So after accounts, you can basically do this and use this token decimals here. And in terms of supply, I can declare this one here. Mm, It's not initialized. Now I need to say that, the token metadata pointer is initialized for this one. Extensions metadata pointer authority equals to pair extensions metadata pointer metadata address equals to mint account. Um, so in the context itself, you have pretty much it. It gets initialized on the chain, and you have these details. Mint authority is not the mint account, but it's a payer. Yeah, this should be fine. Now, let's go and write the code to kind of like create the token 2022 mint. So let token metadata equals to, okay, I think I need syntax highlighting for this one. So let me go and create, I mean, use this instruction in Libaris. Better way. Okay, I have declared to create token with metadata instruction in Libaris. Mhm. Let me create a struct token metadata. Data equals to token metadata name token name. It is moved here. Symbol token symbol. URI is token URI. Okay. Okay. No, it's not. Why is this? Okay. Not here. That's context one pass. Context anchor. Yeah, instruction. Instruction. Yep, that should be fine. Let's remove the supply. Where does it get mint from? You get mint from Anchor SPL token interface because it handles both 2020 and 2022 tokens. So token interface mm, token 2022. This is fine for now. And token metadata, you get token metadata from the Anchor SPL interface itself. That's fine. And now, okay, remaining everything, let's pass it as default. Okay, we have the token metadata ready. And let's now initialize the token metadata. Initialize the token metadata. Okay, token metadata initialize. So for this one, we need to create the context. Let ctx equals to cpa context dot new ctx dot accounts dot token program dot to account info, and then you have token metadata initialize token program id. See, it's dot accounts dot token program dot to account info. What all does it take? Let's just see first. It takes token, it takes a program ID and then metadata, which is mint account, and then it takes a mint method. No, it takes update authority, which will be the payer. It, it takes a mint authority, which is also will be the payer, and it finally takes a mint. So mint is mint account. Yeah, this is fine. You have the context ready. The name and everything is moved here. So just clone this. You pass the token name symbol URI here and unwrap it. You don't need CMS for this. Yeah, we finally return okay. But why did I kind of like initialize token metadata here? Because initializing the token metadata requires, so on Solana, you basically pay rent for however much data you store on chain. So basically, depending upon the amount of metadata or like the data you're storing on chain, you basically need to pay more. So for that, so let data length equals to, you basically need to add 4 more bytes, which is token metadata dot get pad length. I need to import this one. Import this straight. Use SPL type length value variable length pack slash variable pack. Now you get like get pack length. This is strange. Variable pack length, which is still to the metadata interface. Let's just add this to the cargo. Cargo from check the latest version 0. So here we're adding 4 for like 2 for type and plus 2 plus 2 for length. And then you have 2. So for the additional amount of space that you're using, you need to pay the additional amount of, you need to transfer the additional amount of lamp ports to that mint address. So get the additional number of lamp ports required. So lamp ports equals to data length dot length as v64 into default lamp, lamp ports per byte year into default lamp ports exemption something exemption threshold as U64. So, so it basically just transfer these many lamp ports to the main address now. So just do transfer. Again, like get some context.new cth.accounts dot system program dot to account info transfer from payer to mint account lamp port. Oh, sorry, you don't need your. There you have lamp ports. Unwrap it, run it. Underline. Let's see. Just get these. This is like pure soul transfer. So get it from the Solana program. Underline system program. Or no, system instruction. Transfer trends. This is fine. Return. We finally return the result. Okay. Form for anchor skill. Token metadata interface. Token metadata. Let's add still token metadata interface. Cargo. Terminal. And cargo add this. So no linters as such. I think this is fine for now. Just opening the notes again. What's in the goals? Yeah. How are we going to do this? We'll use Anchor to write smart contract instructions, which we'll call from frontend to create the token mint with extensions. We'll be needing a huge set of instructions to create mints with different extensions. We'll be writing tests in TypeScript and making sure the test pass successfully. So at least for like 1st Jan 2026. First point, we have created the project anchor images plus CSS setup, and then we have written an instruction to create a token 2022 mint with meta data extension. Okay. So yeah, I think this is just the beginning. In next steps, we will write tests for the above instruction. We will then move on to probably like transfer key and then to transfer hook.